All right, so let's start over again. These little instructions here are training wheels that are not going to continue. You'll need to come up with these on your own, but let's just use them. Okay, let's use or first find our function, which will be x cubed. And then we want to make our delta x as small as possible. So I'm going to suggest that we use the a as 2 and our delta x as negative 0.001. All right, so let's go find our dy. So our dy is the derivative, so 3x squared dx. So 3 times 2 squared times negative 0.001. So that gives me dy equaling 0.012. All right, so negative. All right, so then, so that's my dy. So again, I want to find L of the y value on the tangent line of 2 minus 0.001, or that's the same thing as saying L of 1.999. So that's going to equal f of a, so the function evaluated at 2 plus my dy, so it's going to be 8 minus 0.012, which is 7.988. All right, let's move on without the training wheels. We can do it all here. All right, so let's think about what our function needs to be first. So our function has got to be e to the x. All right, and I'm thinking the nice number a that I want to start with is 0. And then the delta x, the bit I'm moving away from 0, is negative 0.03. All right, so let's go again. Go find the dy. So that's the derivative, e to the x dx. So I'm using 0 in for x and negative 0.03. So my dy is negative 0.03. So my linearization at negative 0.03 is equal to f of a, f of 0, plus my dy. So f of 0 using the function at 0, that's e to the 0. Let's put it in there for effect so you know what I'm doing. And then minus the 0.03. So that's 1 minus 0.03. And that gives us 0.97. All right. So now we move into the territory that we have to use radians when we're doing these. Must use radians, so I must change the degrees to radians. Let's start off with the degrees and we'll move along and changing it to radians as we go. So our function you see is going to be tangent of x. So the nice angle that I want to find the slope of the tangent line at is going to be 45 degrees, and then my delta x will be 2 degrees. Okay, so let's change this to radians right away. So you know that this is pi over 4, and then you know that to change degrees to radians, you multiply by pi over 180. So that gives us pi over 90 radians for the delta x. All right, let's go find the dy, which is the derivative, secant squared of x dx. So I'm going to do secant squared of pi over 4 times the dx, which is pi over 90. So secant squared of pi over 4, so let's put the squared outside. Squared on the outside, so this is going to be 2 over root 2, because it's secant, which is 1 over the cosine, times the pi over 90. So this will give me a 4 over a 2, or 2 squared, so that's 4 times pi over 90. All right, so let's see, 2 pi over 45 would be the dy. All right, so let's find L of this 47 degrees, which was going to be f of the nice a, which is f of pi over 4, plus my dy. So tangent of pi over 4 I know is 1, and then I'll have plus 2 pi over 45. All right, let's do another one with the radian, or changing it to radians just to make sure that we're good on this. Okay, so here I see 29 degrees, and I see that the function's going to have to be cosine. So I have cosine of x as the function. My nice number a, I'm going to use 30 degrees, and then my delta x will be negative 1 degree. So I know 30 degrees is pi over 6, and I'm going to change this to radians by multiplying it by pi over 180, so I get negative pi over 180. All right, so dy is the derivative, so negative sine of x dx. So I have negative sine of pi over 6 times the negative pi over 180. So I can see that the two negatives are going to cancel out. Sine of pi over 6 is 1/2. So I have a 1/2 times a pi over 180 for my dy. So my linearization at 29 degrees will be f of a, f of the pi over 6, plus my dy. So f sine or cosine of pi over 6, because I'm using in here, be root 3 over 2 plus my pi over 360. And that's it.